All right, so we're in section 4.3, graphing proportional relationships. All right, there's a couple things you need to know about proportional relationships. When the x and y values, okay, so this formula up here, is this in your notes or is this a blank?
It's in our notes.
Okay, that's real important. Like circle it or put a star next to it. This y equals mx. This is our foundation for our lesson today. Y equals mx. And actually, it's the first part of my slope-intercept form. Do you guys remember this formula? Y equals mx plus b. You guys remember me teaching you that in 4.1? Okay. So the x and the y in that formula, they show a consistent pattern. And the value of m, does anybody remember what we learned yesterday that m stood for? Can anybody raise your hand and tell me, what did m stand for? Do you guys remember what did m stand for? It started with an S. Slope. Slope. M stood for the slope. But more specifically today, M stands for rate. The rate. Okay, so we know that a rate tells us, basically in this scenario, the connection between my x and my y. How are the values connected? So proportional relationships assume that the y-intercept, okay, that's why the b is not here in a proportional relationship, because it's 0. And when something is 0, do we even have to write it? When something is 0? No, we don't have to write it. The plus 0 basically just means it doesn't exist. So what does that mean then specifically? It means when the x value is 0, the line will pass through the origin. And that's going to make more sense in a minute once I start giving you some examples. Okay? All right, so do we have all this kind of copied down? All right, so I'm going to give you your first scenario. Has anybody ever ridden in like an Uber or a taxi or anything, like maybe on vacation or whatnot? Okay, so here's your scenario. All right, it's let's say it's $2 per mile that you ride. $2 per mile. So when you first get in the taxi, okay, let's say that X stands for miles. So my X, it would stand for miles, and my Y would stand for how much money it costs. You with me so far? So X is the miles, Y is how much money it costs. Let's say I get in the taxi and I just sit there. I go 0 miles. I'm like, hey, what's up? I don't need to go anywhere. I'm just sitting here. Okay, assuming that they charge by the mile, if I go 0 miles, how much am I paying? $0. $0. A proportional relationship has a 0-0 basis. Okay, meaning if I put a 0 in for X, that means Y is also going to be 0. Now, if I go a mile, I'm going to pay $2. If I go 2 miles, I'm going to pay $4. There is a pattern, okay? But proportional relationships start at the 0-0. So let's look at example 1. In example 1, I want you to circle a couple of things in this scenario. I'm going to graph the proportional relationship. So right here it tells me the relationship is proportional, okay? Where X is the ounces of ice cream. I want you to highlight or circle X and what X stands for. What does it stand for? Ounces of ice cream. X stands for the ounces of ice cream. That's this X right here in the formula. And Y, I want you to circle or highlight Y. That's not my highlighter. Okay, Y is what? What is Y? The total cost. Has anybody ever been to like Yobi or Sweet Frog, or what are some other like froyo places?
I've been to Smoothie King.
Okay, Smoothie King. Maybe. Do they have the on-demand ones that you can just kind of like fill up your smoothies? Have you ever been to a froyo place? Okay, right? Yep, that's that one. That's I think that one's a Yobi. Okay, think about it, guys. Okay, pay attention. So we've all been to one of those ice cream places where they weigh your cup at the end. Okay, that's what's happening here in this scenario. So if I go in and all I do is kind of taste test or whatever, and I don't actually put anything on that scale to weigh, if I have a 0, if I don't purchase any ounces of ice cream, how How much is it going to cost me? $0. So, yeah, I know. That's a little sketchy, right? You go in and do all the taste testing, but you don't buy anything. Don't do that. Okay? All right. So, I need a table of values. Remember, guys, remember back to 4.1. I can't graph a proportional relationship. I can't graph an equation without X and Y values. So, set up your table. Okay, does anybody remember from 4.1 what my standard set of X values was, Mason?
-1, 0, and 2.
-1, 0, and 2. Don't write them. Think about what we're doing here. X stands for ounces of ice cream. So can I walk up to the counter and say, I'd like to order -1 ounces of ice cream for my X value? No, you can't order a negative amount of something. So for proportional relationships, I'm going to have 0, 1, and 2. I'm still going to keep it basic, guys. But I can't have a negative value. Okay? So be careful on proportional relationships. They're going to give you a scenario. If that scenario can't have a negative value, don't plug in a negative number for X. Is that making sense at all? Okay? You guys following along? There's a lot of words in today's lesson, so I'm trying to, kind of keep you guys engaged as much as I can. All right, so think about it. Remember what I just said. X stands for what? What did you highlight? X stands for what?
Ounces of ice
Ounces of ice cream. So I walk up to the counter and I order 0 ounces of ice cream. First of all, they're going to look at you like, what are you doing here then? Okay, right? But if I say I'd like to order 0 ounces of ice cream and I plug in a 0 for X, what's 4 times 0? 0. So I'm going to pay $0. Do you see that? All right. 0 ounces of ice cream means I pay nothing. I'm going to plot my point at 0, 0. I think you guys have a graph there where you can plot your point at 0, 0. All right. So now what happens when I plug in a 1? What happens when I plug in a 1?
It's 4.
What's 4 times 1?
4.
4. Can anybody put this, raise your hand, put this into a sentence just like I just did 0, 0? Can anybody put that into a sentence, the 1, 4? If you can do this, it's clicking. If you can do this, Nick?
Can I get 1 ounce of ice cream for $4?
Exactly. If I buy 1 ounce of ice cream, I'm going to pay what? $4. So right there, that's the heart of what we're learning in today's lesson. To take my X and my Y and to give it a label. Now X is ice cream and Y is money. And I just put it into a sentence. That's exactly what we're learning today. All right, so what about 2? What about 2? What's going to be my Y value? Kelsey, could you tell me that one? If I plugged in a 2, what would be my Y value? 8. Okay. Could you tell me what that would sound like in a sentence?
2 ounces of ice cream.
Perfect. If I buy 2 ounces of ice cream, it's going to cost me $8. Let's go ahead and plot those other 2 points. Over 1, up 4. And over 2, up 8. Doesn't this line look pretty familiar to 4.1 when I graphed a linear equation?
Yes, it does.
It's going to be a straight line. But here's the deal with proportional relationships, and we just talked about this in our terms. It will always pass through the origin. It will always pass through 0, 0. All right, do I have your attention? Okay, meaning if I plug in 0 for X, my Y value will be 0. Okay, so I have one more step though. I have to interpret the slope. All right, so remember guys, remember your formula. Y equals mx. Which variable stands for slope? M. Okay, so based on the values that I've already plugged in, can anybody raise your hand and tell me how much would you pay for 3 ounces of ice cream? It's not on here, but how much would you pay, Connor? $12. You pay $12. How much would you pay? Maybe someone else knows. How much would you pay for 5 ounces? Micah?
$20.
Or Nick? What is it? $20. What did you do? What did you do to find those totals?
You multiply 5 times 4.
4 is your rate. 4 is your rate. So 4 What it's asking you to do is interpret this slope. Here's how I put it into a sentence. I will pay, you can say you will pay, I will pay $4 per ounce of ice cream.
Wait, how much is an ounce? I forgot.
There's 16 ounces in a pound. Like most like drinks, like a can of soda is like 12 ounces. So, but this, in this case, ounces is more measured in pounds. So like a pound of hamburger meat or something like that, that would be more similar. Per ounce of ice cream. Okay?
That's a lot of money for ice cream.
All right, so we're about to talk about that. So let's say that y equals 4x. This is Yobi, okay? Let's say, has anybody ever seen like a Walgreens and a CVS open right next to each other? Has anybody ever seen that? It's so obnoxious. It's like, what in the world? You could have put anything there, right? Okay, so let's say this is Sweet Frog. All right, listen, guys. Let's say, I said this one was Sweet Frog or Yobi? Okay, so this one's Yobi. I gotta label it or I'm gonna get them mixed up. Let's say it's Sweet Frog. I'm going to do SF for Sweet Frog. It opens up right next door at y equals 2x.
Yes.
Why are you saying yes?
Because it's less money.
Because it's cheaper. I can literally get double the ice cream for the same amount of money. So you see, guys, that number in front of x, that's my rate. Okay? And now, what do you think that's going to force Yobi to do? They're going to drop their price, or they're going to have nobody in their store, or maybe they're going to have to run some specials. Okay? So do you see how we literally have taken, all right, so pay attention to this, guys. This is real important. We literally have taken an equation like y equals mx, which really meant nothing to us before today's lesson. And now, doesn't it kind of have a whole new meaning to it? Okay? Because now we understand that slope, or the rate, affects the relationship between x and y. All right? That's what we're doing. Yes?
You just reminded me of something. Yesterday, it was No Wait Wednesday at the what you call it.
All right. Oh, yeah. Yeah, they do that. And that's like a marketing thing. All right, so in example 2, this is real important because this is 4 questions on your homework tonight. And it's on your quiz, and it's on your test. Okay? Does the graph and does the table represent a proportional relationship? So in example 1, I graphed one. Now I have to determine, does it? And if it does, I have to write the equation. Okay? So let's see what this looks like here. All right? On a graph, it's very simple. It's one step to determine if it's a proportional relationship. And that is to see if the line passes through the origin. Does the line pass through the origin on this graph? Yes. Then your answer is yes. That's the easy part. If it passes, literally 2 questions on your homework, all you have to do is see, does it pass through the origin? If it does, your answer is yes. If it does not, then your answer is no. So this would be yes. Here's your reason why. The line passes through the origin. Sorry, I didn't mean to hit that button. The line passes through the origin. If your answer is yes, you must write the equation. Okay? You must write the equation, which means you have to pick a point on the graph. Please do not pick a point where the x and y like don't intersect exactly right. Okay? So let's say I pick this point right here. What is the ordered pair? Do you see how it really crosses like perfectly? 2 what? 2, -2, right? Okay, so this is 2, -2. I need you to take that ordered pair. You could pick any point on this graph as long as it intersects perfectly. And I want you to plug it into your formula y equals mx. Where x, you would plug in your x value, and y, you would plug in your y value. Are you guys following me so far? So which one is your x value? It's 2, right?
-2.
Yeah, well, y is -2. So -2 equals m times +2. Okay? Is there a better way I could write this, though? Like a variable times a number? How do I really teach you to write that?
2m.
2m. So just automatically write it that way. 2m, okay? What would I do to solve for m now? How could I get m by itself? There's a 2 connected to it. Divide by 2, okay? Divide by 2. What's negative 2 divided by 2? I heard it, negative 1. M equals negative 1. So now that I know my slope, I can write my equation. Y equals, plug in negative 1 for m and x. This is my equation, okay? So the first part of your answer is real simple. Does it pass through the origin or not? Okay? If it does, pick an ordered pair. This part's going to take a little bit of practice. Pick an ordered pair, plug it in for x and y in your formula. If you forget the formula, you will have nothing to plug it into. And then solve for m, plug that value in for m. All right?
You couldn't choose 0, 0.
If you chose 0, 0, there's, no, you can't. Because if you chose 0, 0, what number times 0 would equal 0? You wouldn't be able to figure out m. That's actually a great question. That's a great question. Because you wouldn't have known it was negative 1 because 0 times anything would be 0. So you do have to pick a different order pair. All right, now let's look at the second one. On the second one, when you have a table, okay, this one you might find to be a little easier. When you have a table, again, you have to figure out what would I multiply x by or divide? What would I multiply or divide x by to get to y? So what could I multiply my x value by to get to 4? Multiply by 2. So whatever I have to do to x to get y, that number is my slope. Y equals 2x. You just said I had to multiply, right? Right? Okay. So look at your first order pair. If you can find a connection, go ahead and write your equation. But here's the big but. Oh, goodness. That's not what I meant. Here's the big exception, okay? All right. So, so if I plug in 2 for x, 2 times 2 is 4. Let's test it on the next ordered pair, 5. When I plug in 5, okay, what's 2 times 5?
10.
Is it 8?
No.
Okay, so this doesn't work. Yeah, it worked on the first one, but because it didn't work on all of them, I would say no pattern. There's no pattern. There's no pattern here. Sure, I had an equation for the first one, but I had nothing on the other ones.
Wait, so
It didn't work. It has to work on all of them. And you'll see in a minute one that does. Oh, this is 2 different questions, absolutely.
Oh.
So this is 2 questions on your homework. This is 2 questions on your homework. Sometimes you have a graph. Sometimes you have a table. They're completely separate.
Wait, so you always do y equals 2x?
No, it could be, what if y had been an 8? Then it would be y equals 4x.
Oh, so
It's how the x is connected to y. All right, we're going to do some more practice. Okay? All right, go ahead and flip the page, kind of back a few pages. Yes, Josh, you're on the right page. Go ahead and flip back. Okay? So we are looking for a connection. In order for there to be a proportional relationship, I have to be able to do the same operation to x to get to y. Okay? And in a minute, we're going to give a category to my x and y values. So I have to ask myself, is there a way to multiply or divide 10 by a number to get 2?
Divide by 5.
To divide by 5, right? Okay, let's go. Let's throw it back now to 2.5 dilations. Do you guys remember when I had an ordered pair that got smaller, what my scale factor was? Let's say I went from a x value of 10 to 5. When it got smaller, do you guys remember what k was? It was a fraction. So when I had to divide, it was a fraction. Does everybody agree you actually have to divide 10 by something to get 2? What do you divide by? What do you divide 10 by to get 2? 5. Yes. So what is that in a fraction, Nick? 1/5. So here's my theory about what my equation needs to be. 1/5 x. How did I know that? Because 10 divided by 5 is 2. But now I have to test it. Okay?
Yes.
Now I have to test it. Is 15 divided by 3? Is that 5? So you agree it would be 1/5 again? What about 20 and 4?
1/5.
What about 30 and 6?
1/5.
1/5. So my answer, y equals 1/5 x, and my answer is yes. My answer is yes, because this equation works on every ordered pair in the table. All right, I want you guys to work together now. Okay, work together and do the second table. Go ahead and work together and do the second table. Okay, let's see. We're still working. We'll give it another minute. Based on the first ordered pair, can someone raise your hand and tell me what the equation should be, just based on the first ordered pair? Josh?
Y equals 1/4 x.
Ah, beautiful. Great job. Y equals 1/4 x. Now I've got my idea about what it needs to be, but now I need to test it on all of them. Okay, so does it work for 12 to 4? No, I'm going to circle that one. Does it work for 16 to 4? No, you don't. Okay, that's a great question. But does it work for all of them except that one?
Yes.
It doesn't matter that there's only one. It's not like majority rules. If there's even one that breaks the pattern, so Mason just asked, well, did I even need to look at the other two because this one broke the pattern? The answer is no. As soon as you find the one that breaks the pattern, this no longer works. You don't even have to write this, okay? All you would say is no. All right, now, you either need to circle it in the table. Now, on your book, you can't circle it in your book. So here's what I would have you write on your homework. Because, and I don't care if you abbreviate it, the ordered pair 12-4 breaks the pattern. Okay? You're specifically telling me, okay, well, you tell me, what if you only said no? Do I know that you understood it? No, but as soon as you say 12-4, you circle it on a quiz, or you say no, 12-4 is the one that messes it up, I know that you knew what you were looking for.
Can we abbreviate pattern? PAT.
I don't know. I mean, I probably would be fine with that. Okay, it's just a pattern though, all right? Okay, example 4, okay? We're going back to our scenarios here, okay? I want you to read through this. I want you to highlight or circle your X and your Y, okay? And then I also want you to highlight or circle what each variable stands for. So Y stands for what? What does Y stand for, guys? Object on Titan. And X stands for an object on Earth. So Josh, I'm just going to ask you, since you actually knocked it out of the park without me explaining it, what formula did you use?
Y equals mx.
Yes, Y equals mx, okay? So Y stands for what?
The object on
The object on Titan. So this 105, okay, and this 15, okay? So which value, if Y stands for the object on Titan, which number would I plug in for Y? 15. Do you see how that's 15 pounds on Titan? All right, and Y stands for Titan, so I plug in 15 for Y. All right, and then I have M, which I don't know. And what was my X again? It was Earth. And what was the value for Earth? 105. Now, is this how I normally would write a number times a variable?
No.
No, how would I write it?
105.
105M, okay? So now I have to do something to solve for M. Again, if I can find my rate, that conversion rate, I could literally solve for any of these. How could I solve for M? No. Divide by 105. This is going to get a little tricky. 105 is connected to M. Now I'm going to need to reduce this. M equals 15 over 105. Can you guys think of a common factor I could reduce it by? 15 or not 10, but 5. 5. Let's start with 5. 5 is going to be the common one. If I reduce it by 5, I get 3 over 21. But is that fully reduced?
7.
Yes, 1 over 7. So what does this mean? M equals 1 over 7. Go back to your scenario. Your x compared to your y. 1/7 is my rate. What does this mean about my weights? I don't want to give away too much. Okay? Remember how we had the 4 from the ice cream example? And you said, oh, it's going to be $4 per ounce that I buy.
Also, it's gonna
It'd
be
be one.
7.
What's going to be 1/7?
An object on Titan is going to be 1/7 of the object on Earth.
You see that? Okay. So remember what X stood for. So an object on Titan, do you guys agree that Y was Titan?
Yes.
Is going to be 1/7 of the object on Earth. That's the interpretation of the slope. Whenever I ask you to interpret the slope, I want you to show me how that value connects X and Y. Do you see how we did that? That the weight on Titan will be 1/7 of the weight on Earth. So now that you know 1/7, let's say that something weighs 49 pounds on Earth. How much is it going to weigh on Titan? 7 pounds. If it weighs 5 pounds on Titan, how much will it weigh on Earth?
40. No, 35.
35. Do you see how we did that? Now we're using our rate to connect X and Y together. There's a pattern. So let's answer B now. If something weighs 3.5 pounds on Titan, how much will it weigh on Earth?
3 pounds?
If it weighs 3.5 pounds on Titan, now I know my conversion rate, I know my rate. If it weighs 3.5 pounds on Titan, how much will it weigh on Earth?
24.5.
24.5 pounds. How did I find that? I said, okay, I know Titan. Remember, Titan was my Y value. I know it's 1/7 of the weight on Earth, but I don't know Earth. How can I solve for X? I can multiply both sides by 7 over 1. Multiply both sides by 7. You see, I use my formula as my basis. X equals 24.5. Okay, make sure you label pounds on Earth.
That's a lot.
And don't say ear because that's an ear. So you have to write out the whole Earth. Okay, my abbreviation people. Okay, 24.5 pounds on Earth.
Stop.
How do we do, guys? I feel like we kind of did okay on that.
I didn't
All right.
really-
So we view that Y equals MX a lot different now, right? Because X has a label and Y has a label. This is actually on your midterm. That's how far into it we take it. It's even on your final exam. All right. It's real important. But you guys did well with it, okay? And we're gonna keep practicing and keep practicing. All right. So great job today.